so glad to see you. So glad to see that it's the end of the semester. I think faculty and the students alike enjoy kind of the end of the semester as it comes to an end. Maybe faculty more than the students, because you don't know that you have a lot more still to go, exams. It's all going to come to a good end. So I have Alex Medias, who has worked with Dr. Dubois on a research project, and he's going to present his project. Unfortunately, we do not seem to be able to connect his machine to the overhead projector. So he's going to be at a disadvantage at not having something that you can all see, but he's excellent in explaining ideas. And there's Alex.
All right. So the project was, and all my notes are on my computer, so this is going to be kind of interesting. It was basically taking old programs that wrote scripts and converting them to new programs that wrote scripts. So the challenges with this was the original programs were written in Perl, and I don't know if any of you have worked in Perl, but it is notoriously unreadable, and the program itself was already kind of interesting project. So the other challenge for me was I'd never worked in Python before, so I was also learning Python while learning Perl. So the way this project is kind of laid out is we have the power meter, which plugs into the wall. From that, we plug it into a machine that is the machine under test. So what's happening here, so this is the machine under test. It's being plugged into the power meter, just like you plug in a normal outlet. And then the power meter is being plugged into the wall. From there, we take a USB cord and plug it into the data acquisition machine, which is going to be called the DAC from now on. So we have the DAC and the butt machine, which are also connected through a SSH keygen, assuming you didn't have weird bootlegs going or boot patterns going on. And so yeah, on the machine under test, we have the folder that holds the entire Mantis repo and scripts. So where the scripts are being held is within this folder right here. So it would be under the machine under test. And when everything's being run, we copy, there are a set of files and scripts that are all associated with the DAC that get copied to the DAC machine through the SSH keygen. All right. That's the unitary diagram. Yeah, sure. So with that, I created two. Basically, I had a set of scripts that were already made. I had to take them and make them into a Python script. So the first one was a config wizard, and that what it does is it takes a file called config.txt. The user can name another file that they might want to use. The only problem with that is that if you don't have it formatted correctly, it might come out with some weird stuff. So what we do is we take our I'm gonna get a different pen. We take our config file. It reads into the config wiz, and from that, the config wiz builds a set of data that we can use to build the next configuration file. So with this, Perl did this really easily because Perl has a parsing function. Python doesn't. So what we did was we simply just put it into a dictionary and stored it as that. From there, we write back to the config file, and there we go. The next script is the script gen. And from this, we actually generate 3 script files, and I don't remember the names off the top of my head, but one is the DAC collection. I'm going to go back to that, actually. So, actually, this is just simply collection script, and metric script. Then gen DAC. So this is originally it was a Perl file. These are SSH files that are generated by this Perl file. And from there we also do a read from the config file. Now what's very important is that the config wiz actually built the right config file with everything that it needs. Because if it doesn't, the script gen it will run, but it will generate really weird scripts that might have an error when they are trying to run. They try to run. And trying to debug those is kind of difficult, especially when they're copying over to each other. So from that, and then within these scripts, they each have their own little tasks that they do that are associated with this project. And they actually end up generating their own scripts as well. So we actually have from DAC, we have the calibrate script. And then we also have the evaluation script. And basically what these do is, all these do, calibrate, as the name implies, it sets up the data that it takes the DAC machine, goes into the MUT, and it finds the data, finds where it should be located, and then says, all right, I want to format it in this specific manner. And how that is determined is however the config whiz has set this to be set up. The evaluation script actually takes the data and copies it back over into the machine or the DAC machine, where it can be evaluated and made into models and test and something human readable as we would desire. The metric script actually is pretty simple. What it does is it generates metrics. So within the metric script, again, through our config file, we've already set programs that we want to run. So the simple one would be sleep 180 seconds. So the program says, I'm going to test how much power and how much memory, how much disk I use when I run sleep 180 seconds. And basically what the metric script does is it runs that program while it's ready, while the DAC scripts are actually collecting the data still. And it also creates that's the wrong one. And the scripts are generated, but they're not collected at this point. So they will stay on the machine under test, but they do not get moved to the data acquisition machine until we run either the collection script or the gen DAC script. And then the gen DAC script, it creates the files that we're going to keep all the benchmark data in. So that's just the raw data that we got from the machine under test and the metric file. And from there, we actually will read it and then read it and copy it over to the data acquisition machine, and it will also kill any of the processes that were generated by the metrics on both the machine under test and the data acquisition machine. Great. And there's the pretty diagram that I had. That's the end of my presentation.
Any questions?
Yes.
I have a question. How much of this is Python and Perl? Is it all Python?
So this is actually just a text file, a config file.
Okay.
These two are actually really big Perl files that the project was to convert those into Python.
Okay.
So in theory, you could run the Perl one and get the same results or similar results, and then the Python one will get the similar results. There is a little conundrum here where the Python one generates a different Boolean value, but the script one actually takes into account old config files for that. So someone in the back had that.
Why do you want to change it to Python?
To make it a little bit easier to run, just easier to work with. Because currently, if you wanted to change the file like in a bigger sense, rather than just go into the config file and change it, it was kind of just hard to read. Perl's also slightly outdated, so.
So did you ever compare the metrics between two scripts accomplishing the same thing?
So this machine was the machine under test, and as you can tell, it doesn't like to behave. So one of the issues I ran into was it's dual booting a distro, and for some reason the keygen was going to that distro, not the one that is actually the main distro. So I haven't actually been able to run the tests yet. I plan on doing that tonight when I purge the other partition.
What was the toughest part converting things from Perl to Python, other than maybe understanding the Perl scripts?
Perl has really long conditional statements that aren't readable. So actually one of the bigger challenges with script gen, since it's generating these three scripts, it kind of does them in, it's not true parallel, but it does it where, oh, I'm going to do this part of the collection script and this part here. I'm going to do a little bit of the evaluation script. And it kind of does them based on what is pulled out from the config file. So it's kind of efficient in the way that it only pulls out what it needs once it doesn't keep pulling the same thing multiple times. So part of it was just kind of keeping track of that if-then statement. For those who aren't familiar with Python, you actually have to make sure you're indented correctly. And there was enough if-then statements within one that I actually it was coming back around, wrap around. So it was kind of an interesting little project in that sense. Nice.
Which part of the project do you think you're going to remember most vividly?
Most vividly,
Yeah.
I was probably trying to get that SSH keygen to work, because that was an interesting little error.
Thank you so much, Alex. It did not faze him that his computer didn't work with this system. Just give his presentation. Very good. Thank you.
Yep.
Cameron Hall. Cameron has had a number of different internships over the time that he's been here. Once at Vertigo and once this past summer at Microsoft. And we invited him to share his experience with you. There's Cameron Hall.
Hi guys. So yeah, I'm Cameron Hall. I'm a fourth year CS major going into my hopefully last semester, next semester. And Dr. Shesh asked me to talk a little bit about like the interview processes I went through, how I applied, what the internships were like. So like you mentioned, the first one I had was at Vertigo, a software company in Point Richmond. I was actually recommended for it by my CS 210 teacher, Matt Carrier, my sophomore year. First I had a pretty straightforward over-the-phone interview with HR, like I'm sure all you guys have had for any of the jobs you've ever had. After that, a technical interview, which I was incredibly nervous for as a sophomore, being the first technical interview I've ever had, but it was actually very similar to some of the things we did in Dr. Watts' CS 215 class, so I was prepared for it because of that. After that, I went there with Arthur here and a couple other students from SSU and worked as an intern over the summer. Learned how to write iOS apps, learned Objective-C and Swift. And even after passing the technical interview, I was still really nervous going in. Felt like as going in as a sophomore with Arthur, who was a junior at the time, I believe, and a couple other juniors, I felt like didn't know enough or I wasn't far along enough in my education. But those guys taught me a lot. People at Vertigo taught me a lot, and I was able to catch up and contribute just as much. Following that internship, I worked at Vertigo during the school year for a little while, from campus actually. Went in on the weekends sometimes, and started applying to other internships around the end of my junior year. Around the end of the first semester of my junior year. I applied to about 20 or 30 different places because I've always heard that applying to internships is a numbers game. And the first one I was lucky enough to be recommended for, but the next one I didn't have that luxury, so I applied to as many as I could. Heard back from maybe 3 or 4 and had an interview at 2, both over the phone interviews and then a technical interview. So for Microsoft, I drove down to Sunnyvale, had a technical interview with 4 different engineers, which was significantly more difficult than the first interview. But luckily by that point I had taken CS 315 with Dr. Ravi Kumar and was fairly well prepared for it. There's a couple things that I think he touches in 415, and now that I've taken CS 480, the AI class, I'd like to go back and redo the interviews with what I know now. But they were more challenging. A lot of data structures questions, string manipulation questions. I don't know if you guys are familiar with it, but the N-Queens problem was one of the questions that they asked. So again, I was nervous going in. Didn't feel like I was prepared enough, but I guess I did well, and they gave me an offer for an internship. I moved down to Sunnyvale over the summer and worked with a team called Store Simple in Microsoft's Sunnyvale office. What they do is they make a hybrid cloud storage appliance. Hybrid cloud storage is a combination of local and cloud storage. So if you're a company that has a lot of data to store, what this appliance does is it stores some locally, the data that you don't use frequently, that is less hot, is how they describe it. It gets sent off to a cloud account through Microsoft Azure. And the advantage of this it's a lot cheaper to expand your cloud storage than it is to buy more local storage or buy more offsite physical storage. So it sort of ensures you from having to spend a lot more money on storage space. Again, going in there, I was nervous. I felt like I didn't know enough. But the people there, the other interns, the engineers on my team, they were really helpful. They understood that I was coming there as an intern and I was there to learn. And they definitely taught me a lot. And a big part of that was wanting to be helped, wanting to go around and ask people questions and finding people that are willing to teach you and learning from them. So let's see. What I've kind of taken away from both the interview processes is for the first one, networking was as important as people say it is for me. I was recommended for an internship just by virtue of knowing someone and having a good relationship with them. So that was, I feel lucky to have that happen, but I guess it speaks to how important people say networking is. For the next one, the number of applications I sent out, I think also reinforces what people say. Applying to internships or jobs is a numbers game. The more you apply, the more likely you are to get a response. And sending out 20 or 30, hearing back from 4 reinforced that for me. Another thing was I'd always heard about imposter syndrome. I don't know if you guys are familiar with that, but feeling like I was an inexperienced intern disguised as an experienced intern, or a knowledgeable intern. And yeah, that was a struggle to deal with, but asking for help, getting help from people, knowing what your expectations are helps me cope with that. Let's see, what else? Being willing to be helped and asking questions when I needed help definitely helped me get through everything. As an intern, people knew that I was there to learn. People wanted to help me. People were ready to share their information with me, their knowledge. And the last thing was interviewing well is definitely a skill that you can train and get better at. I read a couple books on interviewing. I practiced interview questions with some of the people from Vertigo, like Arthur, a couple of the other interns that were there. It's definitely something that can be trained. You can practice technical questions. You can practice responding to questions like the HR department will ask you, and you get better at it over time. And I think that definitely helped me get both of the internships. So that's all I have. Questions?
Questions?
How far away was the furthest job you applied to?
Sorry?
Drive time, how far away did you, how far was your scope?
For the working at either or the interviews?
Like just applying?
The furthest was driving to Sunnyvale from here, so not very far. Yeah. Arthur?
Yeah, I was wondering, are there any books you had? Any books you used for preparation?
Cracking the Coding Interview was one that I used that Zach Thompson, the guy that graduated a couple years ago, or I think a year and a half ago right now, he recommended to me, and that was definitely helpful.
Is it IBM?
Yeah.
So where did you find like 20 places to apply to?
Let's see. AngelList was one website I used that listed a bunch of them. Really, if you look online anywhere for a list of tech companies, you can find, if you feel like you don't know any more to apply to, you can look online and there's lists of some you might not think of. Like, I don't know, I applied to pretty much every company I could think of that had a straightforward application process. Okay.
And what are you doing after graduation?
I'm going to work at Microsoft after graduation.
So you have
Yeah.
an offer already?
Yeah. Yeah.
Excellent. Thank you so much.
Thanks, sir.
Dr. Rivoire.
So, at the end of the semester, we like to recognize our student club officers for helping to create an awesome environment for everybody. And it's my job to recognize the officers of Women in Computer Science, or WICS. Partly because they're great and they should be recognized, partly so that if you're interested in WICS, you know these faces and you know who to talk to. So first of all, I want to recognize the president of WICS, Kelly Morales. Thank you. I'm not sure who else is here, but let's find out. So I'd like to recognize the vice president, Cindy Batras, who deserves a round of applause. The WICS treasurer, Dee Dee Powell. The secretary, Melanie Nurnberg. And the event coordinator, Jessica DiVincenzi. Thank you guys so much, and okay, we're doing this.
Sure.
I got the job this time because I realized that there's a definite advantage to having this job. Nobody can take pictures of me.
Thank you.
club in our department is, of course, the Computer Science Club. And it has done a lot of things this semester, a lot of helpful tutoring, regular meetings, getting people together. So I would like to recognize the officers from Computer Science Club, Club Treasurer, Jessica DiVincenzi. The Vice President, Tyler Holland. And the President, Ben Levinsky. Thank you all, and keep up the good work.
So, it's my turn again. So I am responsible for distinction awards, graduation with distinction. As I'm sure you do know, this award goes to students who done well in our program. We have 3 criteria for this particular award. One is based on GPA, and the other is based on service to the department and to other students. And the last one is based really on how well did you learn more than one topic, and how well were you able to weave these topics, independent topics, that you learned in different courses together. This is a very prestigious award at the university, and we're pleased to have so many students who do so well in our program. And I will start here today with Spencer Weishfield. Spencer. It has colors. Thank you, Spencer. Let me just stay here, please. Helen Sam. Martin McFadden. Martin is he currently works at Lawrence Livermore National Labs, and he's going through his security clearance today, so that's why he's not here. Marshall Jankowski. Well done. And finally, Arthur Whitwick. A good semester comes to an end. I know it's heartbreaking, but there it is. A number of things. So as you do know, we are in the process of interviewing candidates for our tenure track position. This position is going to start in fall 2016. As I'm sure you do know, we have a lot of students, more students every year in our program, and we try to offer as many courses as we can, accommodate as many students as we can. And as far as I can tell, we do have students on the wait list, but as far as I can tell, the majority of students do get courses that they need. Is this reasonably true? I do understand sometimes you have to trade off 370 for 355 or vice versa. But still, in spite of that, we need more faculty, and we do have a position to fill. And my hope is that we will have one more position next year. That's not determined yet, but we definitely have the need for it. I think that our students really are going through our program very gracefully. That's truly how I see it. We have, just like any other computer science program, computer science is to some extent unknown to students who take 115, for example, the first course in computing. And eventually, through the first few courses, you get to know what it really is all about and whether this is something that you want to do or not. So there is a rough start everywhere and anywhere. That's part of the nature of this discipline. But the fact of the matter is that our students, it's truly my experience, they're very accommodating, understanding of the situations, understanding of our limits, and understanding what we try to provide for them. And I'm grateful for that. Thank you so much. I am always there in the faculty to help, advising or otherwise. Bring your concerns to us. We wish you a good break. We know that you're going to do well. It's almost there. One more week. Tighten up. Exams. It's going to be over. The end result is back there. Thank you very much for coming. We appreciate it.